For this lesson, we're going to be looking at systems of equations. And a linear system is just when we have more than one equation. We're going to be looking at systems of two equations in two variables. So we'll have an x and a y, or whatever letters they happen to be. We could get to the point, and we might not this year, where we have three equations, and we could potentially have three different variables. The solution of a system is a point, and a point as being x, y ordered pair that makes both equations true. Okay, so whatever x and y works for one equation has to work for both for it to be a solution. And then what that looks like visually is where the two lines cross. So the point of intersection is a solution. So it's where the lines cross. And this is why we're going to start out by this method of solving. So we've already reviewed how we graph linear equations. We're just going to graph both on the same graph, and then we'll just look at it and see where do the lines cross. That would be our solution. So for number one, let's go ahead and graph our first one, y equals 1/2 x minus 3. So our y-intercept is negative 3. So we start at the y-axis, negative 3. The slope is 1/2, so rise 1, run 2, rise 1, run 2. And then I'm actually going to keep doing that because when we're solving by graphing, we have to make sure we are very precise. So instead of just making two lines and instead of 2 points and drawing my line, I'm going to make some more points. So I'm going to go from that point I just made and go up again, up 1/2. And then we talked about equivalent slopes. And we can use those here also. So in this case, we have the slope of 1/2, but that's the same thing as -1/-2. So I'm going to go back to my y-intercept, and this time I'm going to go the equivalent slope, -1 and then -2, -1 and -2. And in doing this, I can make sure that my line is nice and straight. And that's going to help me find a more precise answer. And I'm going to graph the second line. So my y-intercept here is 5. Put my y-intercept here at 5. My slope is -3 as a fraction. That's -3/1. So I can go -3 and then right 1. Or I could also go up 3 and then -1 is left 1. So starting from my y-intercept of 5, I can't go up, so we don't really want to use this one this time. I can go down 3 and right 1. I'm going to keep going down 3 and right 1, down 3 and right 1. And then I'll draw my line nice and straight. And then the solution is going to be the point where they cross. And this is a really good example of why we don't always want to use graphing to solve a system, because these don't cross at a whole number ordered pair. So we have to do some estimating. It's going to cross right here at this point, this orange dot. So the solution to this system would be, we have to approximate. So it looks like the x is 1, 2, a little over 2, so maybe 2.4, because it's not quite to half. And then on the y, it looks like we're at -1, not quite to -2, so maybe -1.8. Anything close to that will be a good estimate of that solution. For number 2, we'll graph the first line, has a y-intercept of 3. Slope would be -4 or -4/1. So down 4, 1, 2, 3, 4, and a +1. Down 1, 2, 3, 4, and a +1. And I don't have enough room to go up 4. So then I'm just going to use those dots to make my line as straight as I can. And then I'll graph my other line. Because then we have to remember that when there's no number in front of the x, no coefficient, then it's a 1. And when there's no y-intercept, it must be because it was a 0 and we didn't have to write it. So in this case, my y-intercept is 0, and my slope is 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. 1 over 1 is the same thing as negative 1 over negative 1. So I can go down 1 over 1, down 1 over 1, and repeat. So then I can make a nice straight graph. And again, they don't cross on a whole number of points with the estimate. Maybe they cross at 0.5, 0.5, or something close to that. For number 3, we have to write these in our slope-intercept form first. And I'm just going to use this space off to the left to do that. So we have 4x minus y equals to negative 1. We're going to subtract the 4x from both sides. That leaves us with a negative y. Don't forget to bring down that negative sign because we have not used it yet. Is equal to a negative 4x minus 1. We're not done yet because we still have that negative sign in front of the y. Even though there's no number, we can put a number there, so there's really a negative 1. So now I've got to divide everything by negative 1 because we need just plain y, not negative y. And that's going to give me positive 4x and a positive 1. So let's go ahead and graph that one. Y-intercept is 1. Slope is 4, or 4 over 1. So up 4, 1, 2, 3, 4 over 1. And then I don't have any more room, so instead I can go negative 4 and negative 1. So I go back to my y-intercept and go the opposite direction. 1, 2, 3, 4 over 1. And since that's all the space I have, I'm going to use those to try to draw my line as straight as possible. And then we're going to repeat for the next one. We got 2x plus y equals negative 5. Minus a 2x from both sides. Y equals negative 2x minus 5. So our y-intercept is negative 5. And our slope is going to be a negative 2 over 1. Well, I can't go down, so we use the equivalent one of positive 2 over negative 1. So go up 2 and negative 1. And notice that we already had a dot there. So this is going to have a nice answer. Go up 2 over 1, 2 and negative 1, up 2 and negative 1. And this time, they crossed at the exact point. That point was on both lines. And that is at the point negative 1, negative 3. So this has an exact answer. We don't have to estimate. For number 4, let's refresh our memory on what these two special cases look like when there's only an x or only a y. If you have some room on the left side of your paper here, we're going to write it over here. So if it's an x equals some number, it's going to be a vertical line. If it's a y equals some number, it's a horizontal line because it's only going to go through x at that number, or it's only going to go through y at that number. So we said the x equals is going to be a vertical. So our x equals negative 3. For our graph, where is x negative 3? Right here. And then x has to stay negative 3. It can't be anything else. So x is negative 3 here, and here, and here, and x is negative 3 here, and x is negative 3 here. So that's why it forms that vertical line. And then the y equals 5 will be a horizontal line where y is 5. So y is 5 here. Y is also 5 here, and here, and here. Y is 5 in all these places. So it makes that horizontal line. And then the point where they cross right here. This is another perfect whole number answer. They cross at the point negative 3, 5 if we were to count on the graph, -3 and then a 5. So solving by graphing is one way to solve a system. It's not always the best way, as we can see in numbers 1 and 2, where we had to estimate what that answer was because it wasn't a perfect whole number answer. So that's why we might not always want to use solving by graphing, and we'll learn 2 other ways we could solve a system.